So let's talk about this interesting aspect of the Big Bang. And here I'm coming home from work, and we're going to talk about the Big Bang. Yeah. And here's the trippy thing. Okay, and this is like stuff lay people like me, discovers. Like scientists know this. I'm not pretending that I'm an astrophysics. I'm like a lay knowledge of astrophysics, and a lifetime of interest. So I don't know about you, for me, and I think for a lot of other people, because I've asked about this, when they think of the Big Bang, complicated intersection, I guess I'll go, I made it. When they think about the Big Bang, they think there was all this energy at the beginning of the universe, and all compressed, and then that energy exploded out. And you might think of it as, fireworks, for example. It explodes out, and you see lights, and everything spins around, and that we're kind of in that slow-mo process, obviously, not really analogous to an explosion in the way that we think of it, that happens suddenly with a big bang and is over, right? So a little bit different than that. But we do think about in the terms of that analogy, like there's a middle and there's a boom, and everything now that is spinning out out of that that initial explosion, right? That's what made the universe what it is. That's what threw out energy in such a way that stars formed and galaxies formed and planets orbited each other and all that stuff. Okay, that is incorrect. That is not what the Big Bang is or means. Now, when the term was originally coined, I'm not sure that it was really understood the way it's understood now. So it may be that originally that made more sense. But the kind of the consensus today about how the universe has evolved is that initially the universe was much smaller than it is now. And in that situation, matter was highly compressed and highly dense, okay? And it was much hotter. Why? Because compression and density equals heat. They go together, right? And then the universe expanded. And when the universe expanded, the things happened which brought about the current physical configuration of the universe. So the expansion did not happen because of some kind of infusion of energy that led to boom, we don't know why the expansion happened, in fact, but it was the expansion of space that made the whole process happen. It was not the expansion of energy or matter or whatever. It was the expansion of space, of dimensional space, which I find like very mind-bending and very trippy. And I was thinking about how the idea of a big bang as a flash of energy fits so well with what the Bible says, right? In the beginning, God said, let there be light, right? Let there be light. So a Christian, of course, hears Big Bang, and I can tell you that this is true because this is what I thought when I was a Christian. You hear the term Big Bang, and you're like, wow, that's interesting. That sounds a lot like what the Bible says, right? And I gotta tell you what, when I was a Christian, I wasn't like, oh, that proves God or anything. I mean, I thought it was like an interesting kind of proof, but I didn't put a lot of stock in that because I kind of at that time, I knew, look, I'm not a scientist. I don't really understand this fully, and I'm a cautious person. I don't want to just go out there and make some claim without understanding. many other Christians aren't that way at all. And now that I'm not a Christian, of course, I have a completely different view of that. But I just wanted to illustrate that it's easy for the mind of somebody who already believes in God and who thinks Genesis has some kind of something to tell you about origins, that like it's very tempting to reach out to that. And there's an interesting little story about Georges Lemaitre, who was a French Catholic priest who basically gets the credit for discovering the Big Bang. There was another guy that was also working on it before him. I forget his name, and he died in one of the world wars. But Lemaitre basically gets the credit for inventing the Big Bang, for convincing Einstein, because Einstein didn't believe in it. He thought the universe was static. This is just part of the history of science. But so Lemaitre was a very famous priest and scientist. It's kind of an interesting combination. And the Pope, was following his work, and the Pope wanted to do apologetics with this concept of the Big Bang. And Lemaitre said, don't do that. That's not what it's about. That's not what we're doing here, and there really isn't a connection. It's like he saw it as two different realms, And to the Pope's credit, he actually followed that advice, and he didn't push it. So that's kind of interesting. But obviously, since the beginning, this concept has been deeply connected and interwoven with religious ideas. And so I was thinking maybe we should try to change the name of it. And I don't know that scientists have tried. That'd be interesting to figure out. But the Great Expansion, it could be a good name for it, because that's really what it is. And I find it fascinating that we don't really know why space expanded, and there's no clear understanding of what that mechanism would be or why it happened. And so when you talk about a great expansion of something that is already there, then that's completely different. That doesn't really match so well, right? And it's not let there be light, but it's let there be space. If anything, it's let there be space. Let there be more space. Because, models of the origins of the universe don't account for where anything came from. It's just stuff is there, right? And dimensions are there. Now, another interesting a big thing, I guess you'd say, is the question of what is the shape of the universe? Is it like a blob? Is it a sphere? I think we think of it as a sphere, but we probably think of it as a sphere because the visible universe is a sphere, right? In other words, if you look up in the sky and you look around, everything that you can see is essentially, it's like looking through a sphere, and that sphere has a limit, it has an edge to it, right? But don't confuse that with the universe. That's just the visible universe. That's just the objects where light has reached us. As I discussed in another video, but I'll repeat this because I think it's so fun. The universe is very likely much larger than the visible universe, right? So the visible universe, whoa, that dude just passed me. I'm going the speed limit, but it's like this big diesel truck that's going, well, that's cool, no worries. I regularly pass people in my other car, but not in my truck. So yeah, what was I talking about? Right, so there's this thing called the visible universe. That's the light from objects that can reach us. But we can't know for sure, but it seems likely that there is a lot of other objects out there whose light will never reach us. Now, the reason that there are objects whose light will never reach us is because of the expansion of space. So space expands faster than light can travel relative to some objects, right? So the farther out that an object is, then the more the cumulative expansion of space adds up, and the distances between objects, like say between us and a really distant galaxy, that distance, because there's more space, it expands increasingly faster, right? And so that means that even, like, of course, we all know that nothing can travel faster than the speed of light, but the distance between objects can increase at a speed that is greater than the speed of light. And so because of that, an object can emit light that comes to us, but as the light is coming to us, the distance between us grows faster than the light is traveling, right? So the light will never reach us. It's so crazy, right? So there literally are galaxies and stars out there that we can't see. We're never going to see them. And that's a hard limit on what we can know. Like, we will probably never be able to know have a full knowledge of the universe. We'll never be able to make a map of the universe. We'll never be able to trace its edges, if it even has edges. This is a whole theoretical discussion that I don't really know that much about, but apparently it's a live question as to whether the universe has what you would call an edge, or whether it's infinite in extension, or infinite in the sense that it's a certain specialized kind of shape that would have edges. You know, I'll have to dig into that one some other day. But yeah, so our universe, the universe to us, is the visible universe. There's some differences there, but I won't get into them. Like, that's not exactly right, but it is okay. The point is that there is a sphere around us beyond which there is no information that we can know. Like, by definition, by physics, like, you just can't know it. It doesn't matter what happens out there, because there's no causal relationship between that and us. And so it's like we're our own. So in a sense, the visible universe is our universe, and that's all in a sense that matters, because there's no causal connection between us and whatever lies outside of that sphere. So kind of weird, because you could in a way say that the universe is a sphere, practically speaking, but in terms of the laws and principles of physics, it's very likely not a sphere. And so yeah, anyway, fun times here on planet Earth.